Okay, when we talk about extreme rainfall events, we always think of heavy rainfall, and then we look for definitions: 95th percentile, return periods, uh, maybe absolute amounts greater than 150 millimeters per day, and so on. But can droughts also be extreme events? Or you intuitively think maybe droughts grow slowly and cannot be extreme, but um, obviously droughts start with precipitation deficit, and they can just be meteorological droughts. So you take some threshold, and the deficit goes above that threshold, you call it a drought, or that's a meteorological drought. You can have a hydrological drought where stream flow deficits can be used for thresholds, or you have agricultural droughts where typically soil moisture can be a measure of the drought for how that will affect crops, right? But a concept of flash drought has evolved recently, and this is from this paper in Nature Climate Change that uses this definition of flash drought, definition 1, which is typically used for applications in international operations, predictions, and research. It's defined as 50% increase in EDDI towards drying over 2 weeks, sustained for at least another 2 weeks, where EDDI is the evaporative demand drought index. Evaporative demand drought index. This is an experimental drought monitoring and early warning guidance tool. It examines how anomalous the atmospheric evaporative demand E0, also known as the thirst of the atmosphere, so moisture holding capacity of the atmosphere, is. So how anomalous this evaporative demand is for a given location and across a time period of interest. Typically it's rainfall is very heavy, can be in an hour, 2 hours, 3 hours, days, whatever, whereas drought is typically longer time periods, so you have to consider the time period of interest. And EDDI is a multi-scalar quantity, meaning that this period or time scale can vary to capture drying dynamics that themselves operate at different time scales. We generate EDDI at 1 week through 12-month time scales. That's from the US Drought Monitoring website. The second definition from this website or from this paper is Flash Drought Definition 2. Application is in the US operations. 2 category change in the US Drought Monitor in 2 weeks, sustained for at least another 2 weeks. I put this in basically to say that Flash Drought definition is not unique. It's generally considered a deficit that is growing faster than normal, which immediately allows people to create their own definitions. This definition is created for India, looking at the homogeneous precipitation zones and looking at soil moisture percentiles, which is typically one metric for flash droughts. So this paper looks at the pentads going from 1 to 20 here, just as a schematic, and the wet and dry pentads scale is shown here. Flash drought identification in India: 6 homogeneous precipitation regions in India, classified by the India Meteorological Department. Schematic representation of flash drought identification method. Soil moisture decreases from above 40th percentile, over here, this line, to below 20th percentile in no more than 4 pentads during a flash droughts. So you have to drop from the soil moisture percentile has to drop from above 40th percentile to below 20th percentile in 4 pentads, which is 20 days. It is quite subjective, honestly, but once the declined soil moisture increases back to above 25th percentile, flash drought terminates. The green are the high soil moisture percentile to dark red low soil moisture percentile. Color variation represents wet and dry conditions of soil moisture respectively. So keeping that in mind, one can obviously add impacts as one of the measures. How will such a intensification rate of a flash drought affect crops? Could be crop specific: rice, wheat, corn, maize, whatever you want, soybean, and so on. But nonetheless, the frequency of flash droughts in this paper was estimated for each grid as the number of pentads of all the flash droughts with that definition by the total number of pentads during the 1951 to 2018 period in the monsoon season. So you can see that there is a pattern. The flash droughts happen a lot along the Western Ghats where the rainfall is very high, meters typically, and there is a north-south gradient there, and northwest where the signal is very low, desert regions, the flash drought frequency is low, and the Himalayan foothills, northeast, central, eastern, and peninsular India here have higher percentages of flash droughts. Just take it as presented in the paper. So this is looking at each year, looking at the duration of specific flash droughts from 1951 to 2016 or so, and this is the intensity scale used for classifying the flash droughts, and it's looking here specifically at the 1979 flash drought in terms of soil moisture percentile. You can see this large scale deficit extending in this approximate horseshoe pattern over which the monsoon trend is also negative. This is the precipitation anomaly that generated the flash drought. So in this case, the flash drought is initialized with the precipitation deficit, and then other factors like temperature obviously intensify the drought in the following pentads, and this is the temperature anomaly. Hence the temperature anomaly here is obviously critical for driving the flash drought and its intensification rate, because the thirst of the atmosphere goes up with warm temperatures, and then you get a flash drought. This is the third part of this figure. I already explained what the top two were. So here evolution of the 1979 flash drought in India shown using soil moisture. So here is the monsoon season going from the 30th to 55th pentad, and soil moisture percentiles are higher coming into the season, and then it's oscillating in the season, and then this is the period of the flash drought in 1979 where the soil moisture percentile drops below 20th percentile and then recovers to 25th and above after a few pentads. And that's the temperature here shown remains high during these flash drought, and precipitation deficit exists corresponding to the soil moisture deficit. Okay, this paper also presents some impacts on rice and wheat, I think, but you get the idea. So this is showing some flash droughts that have been classified as severe by this paper during 1951 to 2016 or 18, whatever the period, and you can see in each of them the temperature, precipitation, and soil moisture, and here are the patterns of the soil moisture percentiles dropping to less than 20% here in these magenta and reddish dark red colors. So these are the years where there were severe flash droughts: 79, 2001, 1958, and 1986. 1986-87 was an El Nino, a back-to-back drought. 57-58 I think was an El Nino. 2002 was an El Nino that was centered on the dateline. 2001, I don't know if it was anything specific. 1979 also. 78-79 may have been an El Nino, but you can look it up. Okay, this is from another paper from the same group looking at mean sea level pressures and circulation anomalies. So atmospheric anomaly composites for peak flash droughts during 1979 to 2016, anomaly composites of mean sea level pressure in HPA in colors, and the circulation anomalies during the peak of flash drought that occurred in India during 1979 to 2016 for all extreme dry and hot pentads, during extreme wet and cool pentads. Okay, so this is composites for all flash droughts. This is for extreme dry and hot pentads, and this is for extreme wet and cool pentads. So you can see that sea level pressure is high over the Bay of Bengal. It's low in during this period as a composite anomaly from whatever metric was used for climatology to compute the anomalies. And you can see that there is the anticyclonic circulation and cyclonic circulation, and often there is out of phase relation between convection over the Bay of Bengal and over the core monsoon zone. This is centered much more over central western, northwestern India, Gujarat, Rajasthan, this region extending over here. For the extreme dry and hot years, the pattern is same, so cyclone, anticyclone, but this is slightly shifted towards the east, and also has a bigger signature over in terms of sea level pressure over the ocean and in this region over Pakistan and so on. The opposite pattern works for the present for the wet and cool season, where the pattern here is not so much focused on the Bay of Bengal, but there is the low pressure and the cyclonic circulation over the core monsoon zone extending into northwestern, central western India, and the anticyclone now is over the ocean. So this is much more like a the quasi bi-weekly mode that we were looking at. Okay, so the main point I would leave you with is that droughts are now also considered potentially extreme events when they can grow very fast. Obviously, then the question is how will this change in the future? The warming, especially over a country like India, is almost guaranteed, and the models skill in projecting temperatures given the external forcing and the scenario assumptions is much higher. The skill is higher for temperature than for precipitation, especially because the impact of aerosols, direct and indirect solar dimming, microphysics type of impacts create lots of uncertainties, and in the shorter term model uncertainties dominate, and when you go to the longer time horizons closer to 2100, the scenario uncertainties dominate. So there are papers that talk about increasing frequency, intensity of flash droughts into the future, but I'm not going to include that here. When the CMIP 6 projections come out next month, I'm going to go back and I'm going to record a few more podcasts on monsoon projections from CMIP 6 models. For now, I will leave this flash drought here. There is one more podcast on flash droughts using the example of American flash droughts to show how the forecasting of flash droughts is now a significant challenge for the S2S time scale, the sub-seasonal to seasonal time scale, which we have mentioned already, and I have an intra-seasonal time scale lecture of a series of podcasts, as well as S2S forecast course or series of podcasts on my first channel. Okay, so you can look those up. Okay.